Let's now have a look at the other main type of four-stroke engine that is often called diesel engine, and that I call here the compression ignition engine. In the other type of engine, the spark ignition engine, a spark was used to start the combustion. In our case, no spark will be needed because the compression will increase sufficiently the temperature to start the ignition of the fuel and the combustion process. So for this description, I will mostly point out the differences we have for this kind of engine compared to the spark ignition engine. So we'll follow the same order with as first stroke the ignition stroke. And here we already have one first big difference between the two kinds of engines. Here only air is admitted to the cylinder during the ignition stroke instead of the mixture between air and fuel. So here only air will go inside the cylinder. That's the first big difference. Then second big difference will take place during the second stroke, the compression stroke. During the compression stroke, then it's a volumetric compression. The volume is decreasing. It tends to increase pressure and temperature. For the other type of motor, the spark ignition, we were careful not to increase too much the temperature in order to remain below the auto ignition temperature. In this case, it's exactly the reverse. We want to reach the auto ignition temperature of the fuel that is not yet present there, but that will be injected to the cylinder later. So for this, the two same strategies. First, we choose one fuel that has a relatively low auto ignition temperature, and second strategy is to compress more in order to increase more the temperature that can be reached at the end of the compression. So the volumetric compression ratio that corresponds to the ratio between the maximum volume and the clearance volume inside the compressor, inside the cylinder. Here for the compression ignition engine, this volumetric compression ratio is always above 14. So the normal order of magnitude will be 14 to 16 or 17, or this order of magnitude for usual engines. So second main difference, the air is more compressed in order to go over the auto ignition temperature. Then we have new differences here for the ignition of the fuel, because the fuel is not yet present. So instead of having spark plugs at the upper part of the cylinder, now we need injectors that are used to inject the fuel inside the cylinder. In order to inject the fuel needs to be at a higher pressure than the pressure we have inside the system. But in fact, it's even at a way higher pressure, because we want the combustion to be relatively fast, and one stroke usually takes 10 to 20 milliseconds as the order of magnitude. So anyway, the injection needs to be very fast. So for this reason, the fuel is injected at very high pressure, usually over 2,000 bars for recent engines. So there's the injection of the fuel at very high pressure. The fuel is atomized in very small droplets inside the clearance volume, but combustion does not take place in liquid phase, but in gaseous phase. So the droplets first need to evaporate, then we need to have a mixture of the gases in order for the fuel molecule to be close to the oxygen molecule. So we need the fluids to mix up inside this clearance volume, and once the fluid is mixed, because the temperature is already higher than the auto-ignition temperature, then combustion takes place. So these are many differences with the other type of four-stroke engine. And one of the consequences about what is taking place here is that the combustion process is slower than in the spark ignition engine. So in this case, we cannot really neglect the fact that the piston already has time to move down during the combustion. So that's why now this phase it's named 3A. It's the first part of the expansion stroke during which combustion takes place. And so the combustion by bringing heat will tend to increase pressure and temperature, but the expansion, volumetric expansion taking place at the same time will tend to decrease the temperature and the pressure. So both things taking place at the same time, then there will be less increase in pressure during the combustion in this type of engine. Then the rest of the cycle is very similar to the spark ignition engine. The rest of the third stroke is the expansion of the smoke that we have inside the cylinder, and both these steps, so the expansion is the useful transformation that makes it an engine, and then the last stroke with the exhaust valve opened is used to exhaust the smoke from the system and to go back to the initial state where it can start a new cycle. So that's for the main differences we have between the compression ignition engine or diesel engine with the spark ignition engine or gasoline engine.